We've seen how to find the velocity, the rate at which velocity changes from a velocity versus time graph. How do we find displacement from a velocity versus time graph? That is, if we know the velocities of an object that's moving as a function of time, how do we determine the displacement of that object? Now, what do we mean by displacement? By displacement, we mean change in position. Okay, change in where the object is. Often the same as distance. The only difference between distance and displacement is that displacement can be positive or negative. We can go in the positive x direction or the negative x direction, let's say. Whereas change in position, whereas that is distance, is always going to be positive. We don't talk about negative distances, we talk about negative displacements. We denote displacement by delta S. If we want to denote distance, we'll often put absolute value signs around delta S to show that the quantity is always positive. We look first at a velocity versus time graph where the velocity is constant. If we have a constant velocity of 5 meters per second, then the graph of velocity versus time is going to look like this. Here's our constant velocity moving along. Let's say that we want to determine the distance that we move, or the displacement, at this velocity for a period from the t equals 0 point to the t equals 10 point, implying a motion through 10 seconds. Obviously, if we move at 5 meters per second for 10 seconds, we're going to move 50 meters. We can write that out in the form of a calculation. The displacement is always equal to the average velocity times the time interval. And if we have an average velocity of 5 meters per second for 10 seconds, then that's going to multiply out to give us 50 meters. Now, the interesting thing here is we can note that this velocity versus time interval corresponds to the area of this rectangle. The altitude of the rectangle represents the 5 meters per second, and the width represents the 10 seconds, so that when we multiply height times width, we get 5 meters per second times 10 seconds. We get the 50 meter displacement.